So, first quick note, you should have absolutely used a ruler to draw this thing up, okay? Excuse me. Also, a handy thing, it's not on this diagram, but you guys should know a little better that this is a right angle triangle, so we really properly ought to put that little square in the corner to say, yeah, this is 90 degrees. Okay. Then I've got my measurements on there, 9. There's my units, 40. And then this is the side we're trying to find out. Now, this side, it has a name because it's special. What's this side called? It's the hypotenuse. Very good. You can think about it a couple ways. It's the longest side. The longest side. So that means that 9 and 40, this hypotenuse is going to be longer than that for sure. So if you got an answer and it's less than 9 or 40, something has gone amiss. Okay, so just have a look at your answer and check that out. Secondly, it's the side that's opposite the right angle. All right, so there's 2 different ways to think about the hypotenuse. Would someone like to give me a suggestion? What should be the very first line that I write down from this triangle? Yeah, Brandon.
A plus B equals C.
Okay. Yep, so I've got, remember what Pythagoras' theorem is, which is the topic we're finishing off today. I've got the square of the 2 shorter sides, this squared, should be equal to the square of the longer side, right? So I could write down A squared, B squared, C squared, but in this triangle, I know what A, B, and C are. So I'm going to write that down. 9 squared plus 40 squared equals x squared. Okay, so that's what my first line looks like, right? If it's your second line, that's all good, no problem. Now, what's the reason for this? We're not just plucking this out of thin air. It's like, because I think so. What's the actual reason that I should attach on the side of this? What should I say? 2 words? Pythagoras' theorem. Thank you. Pythagoras' theorem. Okay. So there we go. I've stated something true and I've said why it's true. Now what do I do? Yes, Manal.
Is it okay if you had the equation the other way around?
Okay, so if I had, say, x squared on this side and 9 squared plus 40 squared on the right-hand side, that's a great question. What do you guys think? Is it okay to have it the other way around? Do we think it's okay?
Yeah.
I agree with you, but why? Like, is that just random? Sometimes you can, sometimes you can't. Why should that be all right? Yeah, what do you think? Very good. This is an equal sign, right? So both of these things, really we're saying, they're the same. They are identical, in fact. So absolutely we can do it either way. Right? Okay, so now I can do some of these numbers. Now, 9 squared and 40 squared, you may have reached for your calculator for that one, but let's see if we can do it without. 9 squared, I think we know this one. That's 81. 40 squared, that's going to be a big number. 1600, right? 1600 is an easy way to work that out. You can do the 4, that's 16. And that 0, that's like a 10. So 10 times 10 is 100. So 1600. There you go. That works. Okay. That's equal to x squared. Okay, so I'm just going to whack that together. Now, I don't know about you, but this number is too big for me. I don't know what the square root of 1681 is off the top of my head. Okay, so I'm going to reach for my calculator, and it's going to tell me 41. Very good. There you go. So our length is 41 centimeters. X is just a number, right? If you wrote down x equals 41 centimeters, that's not too bad. That's okay. But just think about it. If I put that back up here, then it would be 41 centimeters. Centimeters? Because I've already got centimeters there. So it's a bit like saying an ATM machine or a PIN number, which is a bit redundant. So you don't need to have an extra centimeters there. I'm just going to leave it as 41. Okay. Great. Okay, let's have a go at the second one, and let's do it a little bit quicker. Okay. Let's quickly draw it. That was A, and this is B. I think I drew it that way, didn't I? Yep. 18 and a half, wasn't it? Okay. Now, this time instead of writing out the steps, because I have it there and you can see 1, 2, 3, 4 lines almost every time will be exactly the same. This time, right, you've got this different kind of arrangement because I'm not trying to find the hypotenuse anymore, am I? Right? So my first equation is going to be a little bit different. The thing you're trying to find isn't always there on its own. So what should I write instead? Yes, no?
18.5 squared equals 6 squared plus y squared.
Okay, fantastic. Great. So I can see the same relationship there. Excuse me. And I've got the same reason for it. Pythagoras' theorem. stating your reasons is really important. A computer can tell me numbers, but a human is what I need to give me reasons, okay? All right, now you can crunch that through. I've got a 36 there and a y squared. Someone want to tell me what 18.5 squared is? Who's got it already written down there? Yeah, Ethan.
Oh, wait, no, I haven't got it.
Have you got the afterwards? Yeah? William, do you want to try?
342.25.
342.25. Thank you very much. Okay.
42.25.
You already said that.
Well done. Now, that looks like it's going to turn out awkward, isn't it? If I subtract 36 from both sides, tell me if I'm doing this right. That looks like 306.25? Is that right? Yeah. Now, that looks like it's going to be some awful, messy number. It looks like it's going to be absurd, doesn't it?
Yes.
How will we know if it is or not?
Use your calculator.
Use your calculator just like you did over here. Take the square root, and what do you find? 60? 17.5? So I'm going to write that as 17.5. Okay? So, conveniently, actually, it is kind of a square of a... It's not that bad. Okay, so it's not absurd. There we go, I'm done.